Hello, everyone. It's my great honor to present our work here today. My name is Lin Shi. My topic is detection of hidden feature requests from massive chat message via deep Siamese network. As we all know, OSS developers are distributed across the world. They rarely meet in person. Instead, they coordinate most of their activities through online chatting, such as Slack, Google Hangouts, and HipChat. Developers discuss a wide range of topics in their chat messages, including some development issues, patch reviews, user feedback, and social events. In particular, the user feedbacks are valuable information that are important for software evolution. It includes developers' desired features, complaints, and suggested enhancement to the existing product. Let me show you an example. Here is a part of history chat message from the AngularJS project. I take it from the IRC channel message history. And we can see that one person asked the question, can we use true or false attribute directly in the AngularJS reactive checkbox? And the other guy discussed with him and told him that there is no such feature. And then we can see that there is a hidden feature request from the AngularJS. And these valuable requests are quickly flooded by newly incoming messages and ignored if not documented. Therefore, we are wondering, can we automatically get gathering dialogues that are discussing desired features? However, it is quite challenging to do that. First, it requires a dialogue-wise analysis, and existing approaches on sentence-wise feature request detection cannot be directly used. Therefore, we design a context-aware dialogue model to encoding dialogues. Second, due to the high volume co-ops and a low proportion of ground truth data, it is extremely expensive to label feature request dialogues out from the large volume of chat message. To overcome this challenge, we utilize the few short learning techniques, Siamese network, to do that. And third, as the online chatting involves multiple people, the chat message logs are largely entangled. It also includes noisy data such as duplicate and off-topic messages. In this work, we resolve this challenge by using the state-of-the-art Dialog Disentanglement model. In this work, we propose FRMiner. It has 4 major components. First, we apply the Dialog Disentanglement model to separate dialogues. Second, we build a context-aware dialog model by using bio-LSTM and text CNN. Third, we recast the traditional text classification task of mapping a single dialog to its class into the task of determining whether two dialogues are similar or not by incorporating Siamese network. Finally, we infer the predictive class based on the similarity results produced by the Siamese network. Next, I will introduce the details about the 4 components. First, the first step is dialog disentanglement. We use the disentanglement model published in ACL 19. It is a feed-forward model that predicts the next utterance iteratively until there is no more successor. The model can achieve a good performance. Second, we design a context-aware dialog model. It consists of 4 layers. For input layer, we combine the globe word embedding with part of speech tag to denote a word. And we use the text CNN to encoding the sentence, which is the sequence of the word. And then we use the bio-LSTM to remember the biodirection context information of the dialog. For the output layer, we combine the 2 direction representation as the output vector. And then we construct the Siamese dialog classification network. It consists of 2 context-aware dialog model that share the same structure and parameters. The representation of the paired dialog is projected into a similarity metric, which is a 2-length vector, and we use the softmax to normalize the vector to probabilities, which indicate whether the 2 dialogues are same or different. And with the probabilities indicating same or different dialogues, we need to further infer whether a dialogue is a feature request or not. Therefore, we select n golden dialogues from the labeled data and output n classes for the targeted dialogue. We use a vote strategy to decide the final class by the majority. This is the overview of FRMiner. After training the model, we can predict whether Dialog is requesting feature or not. We evaluate FRMiner on 3 active open source projects. For each project, we manually label ground truths. In total, we reviewed over 1,000 dialogues and identified 139 dialogues that are requesting features. First, we investigate how effective is our approach for detecting hidden feature requests. We compare with 2 advanced sentence-wise baselines and 4 machine learning baselines. Moreover, to demonstrate the contribution of Siamese network and the context-aware dialog model, we also compare with FRMiner, which is plain FRMiner without Siamese network, and it is the context-aware dialog model followed with an additional classification layer. And the average performance on the 3 projects are shown in this figure. And FRMiner significantly outperforms existing baselines in all metrics, and the FRMiner outperforms in FE score. So we can draw the conclusion that both context-aware dialog model and the Siamese network contribute, but the Siamese network contributes significantly that it can improve the learning performance for this task. RQ2 explore how does the Siamese network facilitate feature request detection in detail. First, we use the same size of data to train FRMiner and the FRMiner, and observe the performance enhancement. The FRMiner used the single dialogues, while the FRMiner used the paired dialogue as input. In this figure, we can see that FRMiner can better resolve the classification task than the plain one, and it is easier for the model to recognize whether 2 dialogues belong to the same class, rather than classifying to the exact class directly, especially when the labeled data are few. And then we investigated the sensitivity of data argument by enlarging the data to 5, 10, 20, and 30 times. We can see that performance becomes stable after 5 times. Thus, the 5 times is a trade-off choice between effectiveness and efficiency. In the third RQ, we investigate the generalizability of FRMiner. We train on 2 projects and test on the other one. FRMiner can also achieve high performance on unfitted projects, which indicates that FRMiner is generalizable to other projects. To summarize our work, there are 3 major conclusions. First, the detection hidden feature requests from massive dialogues is prospective and valuable, and both context-aware dialog model and the Siamese contribute, but the Siamese can significantly improve the learning performance. And the FRMiner provides relatively good performance to detect hidden feature requests, and it also outperforms the existing baselines. Yeah, thank you. That's all.